Try all yours.
Okay. Share. So Maria, just let me know if you can see my screen, yeah?
Yes.
Okay. Hi, everyone. So today we're going to do a session on some graphical elements of JSL. I have taken a kind of a practical approach to the first half of this session. I think Yarmo will do some more of the detailed show and tells, but I'm going to just give a couple of practical examples that I've found useful over the last number of years while I do some graphics in my day-to-day work. Now, I work in semiconductors, so I'm going to show some graphical elements related to that, a wafer map, for example, but I'll go through kind of the basics as well about how to draw and present graphical elements. It's quite simple. There's a couple of options, and obviously all the notes will be available at the end. I'll take about 20 minutes. So you can see my screen here. I just have some sample code. And what I'm going to show is, first of all, that, we have this idea of a window in JSL, making a new window, but then we see this function here called graph box. And part of this graph box, you can see there's a frame size, there's a scale, and there's some axis information, but nothing else. And if I simply run this code, what I do is I just get a blank canvas or a graph box. And you can see, I've set it at 500, 500, but if I wanted to make it a different shape, if I wanted to change my scale, I can remake that, and then obviously this is a different scale, different shape, but it's just a blank canvas onto which we want to draw stuff. And the graph box is the fundamental custom graph element in JSL for drawing these kind of objects. So
Troy, can you magnify a little bit, please?
Yeah, exactly. How do I make my font bigger? Is it
Control Shift Plus?
Yeah, there we go. Is that a bit better, Maria?
Thank you.
Okay. So I'm going to just stick with this piece of code, and I'm just going to bring in some graphical elements. So I actually just want to show one quick PowerPoint file here on a rectangle, or drawing a rectangle, which is a very common drawing element in JSL for a graph. I mean, everything is rectangular, bar charts, anything you want to draw is rectangular. And JSL uses this 4 kind of coordinate function, and the last element here is fill, either 0 or 1, to produce a filled rectangle. And the way it works is it's lower left, upper right, lower right. And so you fill in the values for the rectangle function, and you get to draw a rectangle. And you can see lower left here refers to the left x-axis coordinate. Upper left is the top y-axis coordinate, and the right x and the bottom y. So if I just grab a rectangle very simply, and I bring it up into my graph box, and then I rerun it, you'll see that we'll very quickly just draw a very simple unfilled rectangle, because this 0 here says do not fill. We can continue just adding a couple of examples. So here I'm going to add another rectangle. I'm going to redraw this each time. And you can see here I've added a filled rectangle because I've added 1 here instead of the 0. And we can continue with that. Right, we can add circles. Circle has just an XY position for the circle, a diameter, and in this case, it doesn't use a 0 or 1 to fill. It uses the string fill, or you can omit that if you don't want to fill it. Again, the result of that is that you get to draw circular objects. And then in addition, we have line, polygon, and text. So again, just other common graphical elements that you would want to display on either a custom chart or a graph. Then, we'll draw those. And you'll start to see, we have a line here, we have a polygon shape, and we have some text. Now, there's one other thing here that I want to show, which is this path variable. And path is a function that's used to describe an SVG object, which is just an alternative way of drawing any complex shape other than rectangle, circle, polygon, line, or whatever. You can draw them with an SVG. And for those of you who don't know what SVG means, it's called scalar vector graphic. And all it is it's a string of text that describes the path you draw when you want to create or draw an object. So for example, here we have move to position 1, 1. So this is the starting dot here. Then we go horizontal 5, which is this line over here. We go vertical 2, horizontal -5, and the Z returns you to the starting position. Now, the beauty of using SVGs is that you can concatenate them. They look a little messy. You can put commas in between each variable type. But ultimately, an SVG is a much quicker way of rendering a lot of graphical information. And so I'm going to just include 2 SVGs here, just for the purpose of demonstration. I mean, if you're interested in them, and if you're drawing a lot of graphical information, then you'd want to look at how to create these SVG strings. And I would generally create them offline and then include them in my graphic. But we can see here that, you know, an SVG string, let's turn off my top rectangle. You can see here that I've just drawn this SVG string, which is this box down at the bottom corner here. And again, it's no different from using a rectangle. It's just an alternative method. Now, in addition to that, what we want to do is we want to do some customization or format these objects that we've done. And that's very simple. There's some functions for formatting. So we wanted to say add, for example, a pen color. Now we've drawn objects in red. Now, what we notice here is that these objects which are filled don't have the pen color assigned to the outside. That's because the fill has overlaid on top of the outline that we would have drawn in red for each of these objects. So the order of drawing things like outlines and fills is important. And so if we continue on, we can do things like set a specific fill color. So if I want to say set the fill color for this second rectangle, you know, to green, you know, it sets it to green. And what you notice here is that when we apply a format like this fill color green here, it is now persistent for the rest of the script. So if I wanted to change the fill color to be something else for a different object, for example, the polygon, I would just change it here and call it, say, yellow. And then when I run that, it will change the color of the polygon to be different. So the point is that when we assign, when we create our objects, and then when we want to customize them with colors and with line type differences or with any of these formatting attributes, we just need to be aware that they're globally applicable in the layout until you change them. So what I generally do is I create my drawn objects separately, which you'll see, and I style them separately, and then I add them back into the actual new window, the graph box itself. And I'll show you how to do that in a second. So we can just take 1 or 2 more things about for formatting, and if we come to, say, the text part here, and what I'm doing is I'm just going to set the text color, and I'm going to set the text size. And there's 2 ways actually of setting text size. You can set it explicitly here, which actually I'm not going to do, but you can also set it here using text font, which set the font type, the size, whether you want it bold or plain, and the angle. And so we're almost done with this basic stuff. If I run this, you can see that now I've drawn, you know, various shapes, filled, unfilled. I've drawn some text, which is formatted. And the last one, I suppose, really is I can set the line style. So I have a line here, so I can set my line style. If you hover over the line style function, you'll see that it gives you an opportunity to see what the different line styles are: solid, dotted, dashed. So dashed is number 2. And so the last time I run this, I'll get a line style which shows you that it's dashed. And that's the basics basically for drawing on a canvas. Now, obviously, you don't want to draw random objects like this. We want to draw something specific. So, oh, actually, I have one other thing I want to do. I want to get rid of all this, and I want to show how we would draw onto this canvas from an external reference. So let's draw our basic canvas again. And then we come down here, and our canvas has a reference called test_display, and that's the graph box which we just created. It's called test_display. And so we can make a reference to that called frame, because we want to reference the frame box that's part of this display. And now, if I look at the log, and if I look at the frame, you can see when I run frame here, you can see it says it's a display box, frame box. So it's basically a reference pointing to this display item. And now what we can do is we can use these new functions called add graphic script, or edit graphic script, or remove graphic script to add a script outside of the initial generation of the window. And this is how I actually use it in practice. I create a blank canvas like I have here, and then I write my graphical elements of my script separately, and I use the add graphic script to add that script to the frame. So if I run this one, you can see I've added a green circle using pen size of 2, and I filled it, and I've drawn a black outline over it here. Likewise, I can draw another one. So this one, in case, I've just added a graphic script, which is a pen size 2. It's some text that is formatted in this way. Now, so what I would normally do is I would create maybe a function that would external to creating the canvas that would make all of the graphic elements that I want to add to the canvas, and I would add them like this. And if you have them like this, then you can, just for completeness, you can use this thing called edit graphic script, and that gives you an opportunity to change graphics details if you wanted manually, although I don't know why you would do that. And then you have an opportunity to remove the graphic script in the order that they were created as well. Okay, so that's just externally writing graphical elements and adding them to a canvas. Now, so I'm going to now move on to just a practical use of drawing a canvas. And for me, I'm going to draw a wafer map. So I'm going to open just a table I have here. And just to introduce the table very quickly, we just have product, die coordinates in X and Y. We have this zone information, which just splits the wafer map up into different physical radial zones. And we have 4 coordinates, which are the corners, the upper left, upper right, lower left, and lower right that we saw a minute ago when we draw a rectangle. And then I have a center X and Y position for each die as well. And so what we can tell here is that I'm probably going to draw a whole bunch of rectangles, 1 per each row, which is collectively going to create a wafer map. So in this case, I could, if I wanted, just write a graph builder object just to create a wafer map. I have some interactivity, I can select die, that's fine, but it doesn't really look like a wafer map, and it has the coordinates of the die here, but it's not a physical representation of the positions of the die as actually laid out on this wafer, as in these coordinates here. It just shows you, this just shows you the die coordinates from these 2 columns using Graph Builder. So it's not ideal. We want to do something a little bit better that is more representative of the data in the table behind. So what we'll do is, I'll just, I'll run this code here. All I'm doing here is I'm just getting the product name from the product column. I'm getting the number of die, which is the number of rows in the data table. I'm getting this EBR value, which is an edge bead region, which is a keep out zone for, which means all valid die need to be inside this region. I'm just using it because I want to demonstrate something later. And I'm actually using this command here called color by column to assign specific colors to the zone column dependent on the value in the column. So zone 3 is blue, zone 4 is orange, zone 5 is green, for example. And we'll see the reason I do that later. And so I'm going to now just have a quick look at my wafer map function. And although I said, generally speaking, I make the logic outside of the canvas, just for demonstration purpose here, I'm going to just do it within this function just to keep things simple. And the first thing I'm going to do is I'm just going to comment out this part, which is the bit that does drawing the die. And I have exactly the same as what I had above. I have a frame, a graph box with a frame. This time it's 600 by 600. It has a scale. And in this case, I'm just adding my first graphical element, which is a background. And that's just a circle that's light gray in color. And it's going to have a red border. So if I was to run this, you can see that I've drawn my background circle and I have my red border. Now, what's important here is to note is that I've drawn the background circle in gray first and filled it. And then on top of that, I've redrawn the circle and it's going to have a pen color of red. And now what I'm going to do is I'm going to draw the die. And for the die, what you see here is I'm creating a black pen color, and I'm going to fill my die in green, and I'm going to iterate over the table on each row, and I'm going to draw a rectangle based on each row in my table. So for each row here, and these describe the positions of the die I want to draw. I'm going to draw a rectangle. So I will do this incrementally. I will comment this part out first, and now we will draw our wave map. And what you see here now is we have something useful, right? We've taken a table behind and we've drawn a wafer map with the die physically drawn onto this graphic element. And what we see here is that the coordinates here are not the coordinates of the die positions x, y, but rather they are the physical coordinates of the die columns that I have highlighted in the background here. And then finally, I want to add just the coordinates of the die x and y. And here I'm just getting the x and y value for each row. So like 11, 10, 2, 11. And then I'm getting the position that I want to place those die within this canvas. And that's I'm going to use the die center x and y coordinates here. And then I'm going to write text, and that text is going to be different. It's going to be on a different position dependent on the center position of the die for the row I'm drawing. Now that all sounds like a big, that sounds a little bit complex, but basically I'm just going to draw a set of x and y axis. And so what you see here is I've drawn a set of 0 to 13 and 0 to 12 die on the x and y axis, which represents the position of the die from these columns. Now, again, I know that there's a lot of new stuff here. Code will be available later, and you can step through this, turning on and off different sections to see how these elements are drawn. And so this now is a much more useful wafer map than, say, for example, the one that we saw a minute ago. This one. And particularly if you're building, say, an application where you want to describe or show something like a wafer map or another graphical element, something like this is much more representative than something like this on the left. Now, the caveat or the drawback is that when you use something like Graph Builder to draw a map like this, you have the ability to select kind of rows, or to select die, which in turn selects rows in your table behind. But when you draw a canvas item or a graphic item like this, you don't have that selectivity ability. But what you do have is you have the ability to zoom in and to look at your, you can zoom in and examine closely different elements of your graph. Now, where are we? Okay. So then the last thing I'm going to do on just this canvas here is that, just like last time, I'm going to make a reference to my graph box that I've created, and I'm going to add some additional information. So for example, I took at the top of this part of the script, I took this EBR value. So it's the value of 2000. And just to demonstrate that externally, I can still reference and add stuff to this, I'm going to just draw a second circle on this wafer map external to the initial creation of the map. And so you can see I just drew a second circle here. Now, this is where the add graphics script becomes very important. So let's say, for example, I want to overlay defect positions or another data set on top of this graphic. I can do that now externally. So if I had a table, say, of defect coordinates, I would create a graphic script internally. I would create a position for each defect coordinate, and I would draw it onto this wafer map. Or I could draw text information onto it, or I can draw anything I want. So basically, again, I can do add graphic script, and here I've added the details of the product, or I can add anything else I want here after the fact. Okay, so we saw Graph Builder and how it was useful for creating a kind of a map, in my case, and it had some interactivity with the table. And then this one here is a purely graphical item, which is for visualization, but it doesn't really have interactivity. But there is actually a third step where we can combine both, and that is to draw on top of a standard platform like Graph Builder or X by Y plot some graphical elements, and we're going to do that next. So right now, what I'm going to do is I'm going to close my table, and I'm going to reopen it and collect some information. And I'm going to create a bivariate plot, which is just an X by Y plot. And what I'll do is I'll draw this first. I'll comment out this part. and I will draw my bivariate. Okay, so here we have a very similar chart that we drew with Graph Builder, and only this time I'm doing it with X by Y. So, all I'm doing here basically is saying like analyze y by X, die X, die Y. That's essentially all I'm doing is just a bivariate chart. And then, as we've seen many times, save script, say to clipboard, Control-T, Control-V, and I have the code for my bivariate chart. So basically all I've done is I created this bivariate chart, formatted it, and grabbed the code. But what you see now is that in addition to this code, here I added this frame box section into the bivariate chart itself. Now, I've manually added this after the fact. So in other words, I know that if I create a dispatch object and add a frame box into this, I now have a frame box I'm now accessing the frame box as part of the bivariate, and you can see that I've set the background color to be light gray. Now, this is very important because I'm now going to continue to draw on top of this bivariate chart, and I'm going to overlay some graphical elements on this so that I kind of have the best of both worlds. I have an interactive wafer map, but it also has the graphical elements overlaid onto it. And so what I'm going to do here is I'm going to uncomment this section now. And what you see is that all I'm doing is I'm adding a graphic script in a slightly different way. I'm not using a reference here. I'm just adding it inside the bivariate chart. And I'm going to basically add a rectangle over each position of the bivariate die, and that's just using the table in the background again. So let's just run this, and then we'll see what it's doing. And what you see now is that I've taken the rows in the table, and for each row, I've drawn a line around each point, and that's what these two rectangles are doing here. It's drawing a line that is filling in, or it's drawing, first of all, it's drawing a box, a rectangle that is filling in white. You can see the fill color here is white, and then it's drawing a second rectangle, which is the black outline around the edge. And basically what we have now is we have a better looking wafer map that's on a bivariate chart, and it still has its interactivity. So again, I might use this, for example, if I wanted to create a map that I wanted people to be able to interact with and subset out die. And I would use the other one, the purely graphics one, if I wanted to create a visualization that was going to go into a report set. And you still have your ability to access this bivariate chart. So here I'm making a reference to the frame box, and I can still add graphical elements. So I've added a circle here. This one is adding a center circle, and then I can add some text if I wanted. So basically now what I've done is, as I said, I've taken kind of the best of both worlds. I have a graphical element drawn over a bivariate chart, or I can draw on any platform that JMP has, and I still have my ability to interact and make data selections in the underlying table that I can subset. And if I so wanted, I could enhance that a little bit. I could do Control-All. I could set my markers to be something else. And I can come back to my chart, and I can do things like marker size, and I can set it to say a value like 15. And now you kind of have a bit more realistic looking wafer maps, again, with functionality of having the ability to select them and and then subset tables and do additional information on your data. So that's it. That's it for my section. Again, just 3 practical examples of using graphics in a day-to-day application. Very simply using Graph Builder, using pure graphical elements, or combining graphical elements onto an existing platform. And with that, I will stop and hand over to Jarmo. Thanks, everyone.
Okay, hopefully my screen is visible.